Everybody, welcome to another exciting episode of Data Exposed. I'm your host, Scott Klein, and with me back is Jos. Welcome back to the new studios.
Thanks, Scott. Great to be here.
Awesome.
Nice to see the new studios.
These are awesome.
Yeah.
I know.
Pretty cool.
Might have to move my office in here. All right, so take a second for those that haven't met you before. Take a second to introduce yourself.
My name is Jos de Bruin. I'm a program manager with the SQL Server team. And for the past couple of years, I focused on the feature in-memory OLTP, which is also what I'm here to talk about.
Great. Okay. So we had you in, probably a year. We've had you in a couple times. I think the last one was about a year or so ago to talk about in-memory. But you're back to talk about that, and in what capacity this time?
So I want to talk a little bit about in-memory OLTP in SQL Server 2016.
Okay.
We just released SQL Server 2016 a couple of months ago. And the in-memory OLTP feature, it's a great performance feature that allows you to get like really significant manifold performance gains for your transaction processing. And I'm really excited about SQL 2016 because in 2016 we're making it so much easier to use the feature.
Really?
You can. It is much easier to adopt it in a lot of applications.
Okay.
So I think with that, this will be also kind of a new introduction for a lot of people to the in-memory OLTP feature.
So you've got a demo for us. Are we gonna? Can we talk about? Can we talk about how you make it easier to use those and kind of the new things in 2016?
Yeah, we make it especially easier because we implement a lot of features that are available for like traditional tables and stored procedures that were not available in 2014.
Right. Okay.
So for example, your foreign key constraints, your var binary max columns, the OR statement, union all statement. So with all these improvements, and we made a really big leap with all these improvements, there's a lot more apps where you can really leverage in-memory OLTP very easily.
Okay, so kind of a broader, you now have a broader surface area coverage for in-memory.
Yeah, absolutely.
Okay, good.
Absolutely.
All right, well, let's jump right in. What do we got?
Yeah, so what I wanted to show is kind of both a demo of its capabilities and also how you would get started in your own application to implement this technology.
Excellent, okay.
So to set this up, we have here a ticket reservation application, or rather a load simulator. It's a workload simulator that basically generates as many kind of tickets, reservations, as many transactions per second as it can. It is like a one-to-one read-write transactions.
Cool, okay.
And we're starting with we are using SQL Server 2016, but we're starting with your traditional, what we call disk-based tables and your traditional stored procedures.
Okay.
So let's see what kind of performance we can hit here.
So this is a standard disk-based system.
Yeah.
Right? No in-memory implemented yet, right?
No in-memory, but it is SQL 2016.
Okay.
So we see here transaction throughput of about 1,500 transactions per second.
Okay.
Now, as we can see from this dial here is not moving all that much. so maybe that's an indication we're not really hitting our goals here.
Yeah, exactly.
Right. So let's see what we can do about that. So and this is again a transaction processing application. So this technology really for transaction processing.
So behind the scenes, it's doing just a ton of inserts and updates behind the scenes, right?
Yeah. It's insert select. That's what it's doing.
Select. Okay.
So now let's see how to get started with in-memory OLTP here. So I'm going to switch to my Management Studio.
Okay.
And we have in Management Studio something we call a transaction performance analysis report. And this report allows you to identify objects in your database that can really benefit from in-memory OLTP. So I'm just going to right-click on my database. I'm going to say reports, standard reports, and here we have our, this is not popping. We have our transaction performance analysis report.
Okay. Oh, nice. Okay.
And you can look at both at your tables and your stored procedures in this case. So we're going to look at our tables first. This is a pretty simple demo, which actually only has one table. Typically, you would see a bunch of tables in this report, and it will tell you what tables you really want to focus on in your efforts to implement in-memory OLTP.
So where did it get this information, right? Where did this report pull the information from? So obviously there's a process that's looking at your database to go, hey, what's your transaction, like you said, transaction usage, things like that, right? Where does it store this information?
So in SQL Server, we have something we call DMVs.
Okay,
They're dynamic management views. They have been in SQL Server for a long time already.
Yeah.
And they are collecting runtime statistics, things about like which indexes are used, how often, is there any latching, locking going on, which stored procedures are called most often. And this report relies on that information.
Right.
So it is not collecting any additional information. It does not provide any or put any additional burden on the database.
Okay.
Instead, it is leveraging the DMVs that already exist.
Sure, but is it storing that data in like system tables? Where's it pulling this? Where's this report pulling that data from? The system tables?
From the DMVs.
From the DMVs. Okay.
It's essentially running queries against the DMVs in the database.
Okay.
So no additional metrics. In SQL Server 2014, we had something called a management data warehouse, which was used for storing stuff. It was all very complicated to set up, and we wanted to make that a lot easier. So in SQL 2016, you run the report directly against the database, and, and you're done. And you can even do it on down-level versions of SQL Server. You can run the report against the SQL 2008 database if you want.
Okay.
Right.
Yep.
So we identify our database, our table here, ticket reservation detail. So our next step is, so that's the table we really want to focus on. So our next step is, I need to memory optimize that table.
Right, okay.
So again, we built a tool into SQL Server Management Studio. I'm just going to navigate here to my table.
Yep.
Let me actually refresh this view here. We have here our table, ticket reservation detail, and I can right click, and we see here the Memory Optimization Advisor.
Nice.
So that's a tool built into Management Studio to make your table memory optimized.
Okay.
So let me go ahead and get started with the advisor.
Okay.
So information page about what it does. And this is essentially a wizard you click through.
Okay.
First it tests whether there are any unsupported features, because in 2016 we support a lot more features than in 2014. So right now a lot of these things which are green would be red in 2014.
Okay.
But there are still some unsupported features, like for example spatial data types are not supported.
Okay.
But most data types are supported.
Okay.
So we can go through a couple of things you might want to read up on or not.
Yep.
Here you can decide whether you want to copy the data to the new table or not. In most cases you do want to do so, but in this case for demo purposes it's not really necessary.
Okay.
So we can go through, we configure our index, and then we are ready to migrate.
Okay.
So you can, in this view, you can either click the migrate button to do the migration then and there, or you can generate a script, which you may want to kind of inspect the script, make sure it doesn't do anything funky.
Right.
And actually, I also want to show you this script. Therefore, I'm just generating the script and then I will run it. So we have here the actual create table statement for the new memory optimized table. I know that it is memory optimized because of this keyword, memory optimized on.
Yep.
We have here durability equals schema and data.
Okay.
So what that means is that both the schema of the table and the data are durable.
Right, okay.
Because the question I get asked very often is, hey, if it's in memory, what happens if my server crashes or there's a failover?
Yeah, exactly. Is the data backed up? What happens when power goes out? Yeah, exactly.
Exactly. Yeah. So schema and data durability means it is fully durable. All operations on the table are fully logged. This means that if your server crashes, there is an always-on failover. Your data is just there when things come back online.
Now the script, if you scroll up, one of the things that wizard asked was, hey, the file groups. Does that wizard go? Cause in 2014, you had to go. You didn't have that wizard, correct?
The wizard was there.
Oh, was it there? Okay.
So what it does is if there is no memory optimized data file group, it will add that file group in the script In this case, there was already.
Oh, there was one. Okay. Okay.
So that's fine. But so the tool will take care of all these things for you.
Great.
Let me just run it. So I'm making my table now memory optimized.
Okay.
So let me go back now to my tool, my load generator, and we can start this again and see what the performance looks like now. Right. So now our performance is up quite significantly, almost 60,000, factor of about 45.
Yep. Just by moving the.
Just by moving the table to memory optimized.
Okay.
Right.
Wow.
Yeah. So that is that's a pretty significant performance gain already.
Yeah. Let me ask you this, and hopefully this is not a trick question. So, would we be seeing the same performance gains in 2014, or were there improvements in 2016 that says, hey, we even get better just by moving the table, right?
You get better.
Okay.
In 2016. I mean, you still get also in 2014 really dramatic performance gains, but in 2016 we made some further improvements that make things even faster.
Okay. Good.
Okay. Let me stop this right now, and then the next thing I want to do is actually look at the stored procedures.
Okay.
Because if you remember, this report had stored procedures as well. So we can look at those. So let me go back, look at the stored procedure analysis. And stored procedure analysis works pretty similarly.
The same way, yeah.
It identifies the kind of key stored procedures. In this case, we have our batch insert reservations, which is essentially just a helper procedure for the demo.
Yep.
So I can disregard it. And we have one key procedure, insert reservation details. So that's the one I want to focus on.
Okay.
So if I go into my stored procedures, for stored procedures, we have what we call the native compilation advisor.
Okay.
So similarly to the memory optimization advisor,
for the table,
native compilation advisor.
Yeah, because so similar word for the stored procedure.
Yeah, so we're talking about natively compiled stored procedures here.
Yep. Okay.
So I can run that tool. Now this tool does not do the actual migration itself, but it can identify whether there are any features used in a stored procedure that are not compatible with native, where you may need to do some rewrite. And again, in 2016, you will have a lot more green than in 2014 because of union all, case, or all these things. Right?
Okay.
Sorry, not case. Case is not yet supported in 2016, but or union all these things. Right. And in this case, everything looked good for the stored procedure.
Right. Okay.
So I can go ahead and make my stored procedure native. What I'm going to do is I'm going to script my stored procedure as a drop and create. Then, because everything is good from a surface area standpoint, I don't need to change any of the contents of the stored procedure.
Yep.
But I do need to change some annotations. So I'm going to cheat here a little bit. I'm going to copy paste, which I usually do. So this is usually kind of the header information, which you can pretty much use for all your native stored procedures. And I'm just going to replace that here. You will see that there are a couple of things that you need to specify up front when using a natively compiled stored procedure, such as transaction isolation level. For most people, snapshot is good enough, but repeatable read and serializable are also supported. But if you're using, if you don't know what you're using today, or if you're just using the default read committed today, snapshot is going to be what you want to use.
Okay, yep.
And there's language that you need to support. And yeah, I like Dutch. so let's make this Dutch. Okay.
Awesome.
By the way, you could always, also in 2014, specify any language you wanted.
Okay.
But because in demos it is usually English or US English, many people think that's the only thing supported.
Right, okay.
So, but that's
sweet.
But you can support
we'll do Dutch. Awesome.
any language.
Yep.
Yeah, I like it. It's my mother tongue, of course. So,
right.
So what we can do is now start our simulation again, and you will see that there is another kind of step in the transaction throughput, so up to 50-fold transaction throughput that we can get. So even more performance gain that you can get. And in this case, the stored procedure is relatively simple, so it's a simple T-SQL script.
Yep.
Generally, it's the case that the longer the T-SQL script, the more improvement you get from using native compilation.
Right. Okay. Awesome. Okay, and so This was great, and this was if those that were familiar with in-memory, they probably recognize this demo from the 2014. But I think it's still good to revisit and go, hey, look, what's new? What better improvements do we get?
Yeah.
How easy it is to migrate, right? To
Yeah. You saw there it was a lot easier,
Yeah.
especially with the transaction performance analysis report.
Yep.
Can now run directly against the database rather than having to configure data collectors, management data warehouse, all these
yep.
things, right? That gets pretty complicated.
Okay, cool.
So
Very nice.
Yeah, what I like to do now is give kind of a recap and talk about some of the performance numbers and how to use it.
Yep, okay.
How to use the technology. In-memory OLTP, so again, it's optimized for OLTP workloads specifically, so for transaction processing. We have these memory optimized data structures, for example, for these memory optimized tables.
Yep.
And these data structures, they have like optimized code paths for both the data storage as well as the data access.
Yep.
So you in the same amount of time, you can do a lot more operations
Right.
on these tables.
Okay.
The whole architecture is log and latch free.
Yep. Yeah, and that was kind of the difference between disk-based and in-memory is that you're getting rid of that contention, right? The disk-based
Exactly.
contention.
That is why especially in the demo you saw this big performance gain from disk-based just to memory optimized
Tables,
table.
yeah.
Just going to the table. There's no more locking and latching contention.
Right.
So it is completely friction free.
Yeah.
So you can actually fully utilize all the resources in your server.
Yep.
In this case, I had 24 cores available to me. I could use all 24 cores
yeah.
fully to get this kind of performance
Yeah.
profile. Right?
Yep.
And then we have our native compilation to make things even faster.
Yeah. Great.
And what is also a good value proposition of in-memory OLTP compared with some of our competitors' products is that it is fully integrated into SQL Server. So it is a familiar product that you will already know and hopefully love. I love it.
Yep.
You can use your Transact SQL language.
Yep.
You can use Management Studio, SQL Server Data Tools, all your
So
existing
no additional
tools.
no additional install. It's just there and very, like you saw, very
Yeah.
easy to migrate and implement, right? Because it's built right into the engine.
Absolutely.
Yeah.
Absolutely. And then this kind of the technology we built translates into kind of a number of performance benefits.
Yeah.
Well, as we saw, usually when we talk about performance gains that you can get up to 30-fold, in this demo you saw that it was 50. That was, of course, a demo environment.
Yeah.
We are a little bit conservative in our claims here because this is what we have seen with customers.
Yeah, because let's be realistic. It really depends on your workload, the type of OLTP transactions you're doing, right?
Yeah, absolutely,
Right.
absolutely. It really depends kind of on the pattern of the
pattern,
application.
yeah. Awesome demo, but 50,
Not everybody will get to 50 times, but
Yeah,
many
exactly.
people get really significant
Yeah.
performance gains from this. So
well,
typically between 2 and 10-fold.
Yeah, well, even 2 to 10 is significant, right? If you're
Yeah,
gonna, if you've got a 4-hour, process that's running, you cut that down to 2, that's still significant, right?
Yeah. And we have heard from processes that took hours that now take minutes. So you can get really significant gains.
Right.
And in terms of kind of the raw perf numbers that we have seen in the lab, ingesting 10 million rows a second durably, so fully logged, right?
Okay.
Corresponds to 1 gigabyte a second of log generation.
Yeah. Wow. Okay.
That's a really, really large amount of data that you're ingesting every second. And 360,000 transactions per second for kind of an order processing workload with the mixed read-write. And these are all on 4-socket servers.
Okay.
With your 72 cores.
Yep. Okay. Cool.
And one customer that we often like to highlight who got some really good results with the technology is BWin, who was using it for their ASP.NET Session State server, where they have a big scale-out web farm, stateless web farm, and the session state, the state of the user sessions is stored in SQL Server.
Yep.
Already for a long time they have been using SQL Server, but before in-memory OLTP was there, they needed to have 18 physical machines, all with SQL Server installed, in order to support the workload. With in-memory OLTP, they went from 18 to just one server.
One server.
Yeah, that's really big cost savings, both in like capital expense and operational expense.
Their performance gain was phenomenal.
Absolutely. And with their application, when they were testing with SQL 2014, they got 450,000 requests per second in the lab, pushing it as hard as they could.
Yeah.
With 2016, they went up to 1 million requests a second. So more than doubled even.
Very nice.
And the main reason that they had this improvement was that with the expanded feature set in SQL 2016, they could actually put more of their structures in memory, more of their stored procedures could be natively compiled to really leverage these performance benefits.
Right. Wow. Okay. So they went 400 something to 1 million. That's phenomenal.
And this is sustained. This is, let's say, the floor of their testing. It went with peaks up to 1.7.
Okay. So let's just say average. Okay. Good.
This is not average. This is floor.
Floor. Okay. Floor. Okay.
Floor. Yeah.
So anywhere between 1 and 1.7. All right. We'll call that the floor.
Yeah. Okay. Then I do want to kind of give a kind of caution, because we have seen people were thinking we're having some performance bottleneck. We're not really sure where it was. Tried in-memory OLTP and it did not really work out for them.
Yeah.
So I want to kind of conclude this a little bit with talking about when to use and when not to use in-memory OLTP to get performance gains. So yes, you do want to use it if you want to increase your transaction throughput. So let's say your sales order processing and whatnot, your traditional transactional application, you really want to increase your throughput.
Okay.
This is the right technology. Also for improving data ingestion. Right?
Okay.
So if, for example, you have a lot of events are being generated by, let's say, Active Directory domain controllers that you want to persist for auditing purposes, or you have like devices in the field that are measuring like the oil production, for example, right? And they're sending back their data to the server for further analysis. That's I call those data ingestion scenarios. This is a good technology. Many customers use it to improve data ingestion rates. Mm-hmm. Also reducing latency.
Right.
So if you want the call to the database to be as fast as possible, let's say you're placing orders for financial instruments, you're placing that's where you really want them to be placed very fast.
Yeah, you want that. You want to increase the the more number of transactions, right? Without the hang up.
Exactly. Plus, I mean, in sports betting, for example, you can bet on events like whether the next serve in a particular game is going to result in a fault or not.
Right. Yeah.
Right. And there's a very short window between like when the serve is starting to happen and when the player actually hits the ball.
Right.
Right.
Yeah.
So that you have this very short window of time that you need to place the bet.
Right.
So you want low latency in those scenarios. Another is consistent low latency.
Right.
With that, I mean, what happens if you have traditional tables and you have like a transaction processing workload, a lot of orders are being placed, and some event happens, and then maybe it's for financial instruments, maybe a market event, and then there's a burst in activity.
Right.
And then with traditional tables, there you will get contention on all because the locking and the blocking.
Right.
So then you get a spike in the latency. Okay. And with in-memory OLTP, because it's completely lock and latch free, your latency will remain flat.
Okay.
No matter how many transactions there are in the system.
Okay.
As long as you have CPU, of course.
Yep.
Right.
Yep. That makes sense.
And transient data scenarios.
Oh yeah. Okay.
So
you got a lot of data movement, right?
Yeah, well, with transient data scenarios, I mean scenarios where you have some data that you need to store temporarily.
Yeah.
If you're thinking about like session state, for example, there the data is ephemeral in some sense, right? Because the user has a session only for a short time. And even if you lose the session, you can probably recreate it.
Yeah, okay.
Or in ETL, for example, you have an ETL process to load data into a data warehouse. You want to load it, do some transformation, and then persist it in the actual fact and dimension tables.
Okay.
In that case, if there's a failure that happens in the ETL process, you can always restart it because you always have the source data.
Yeah.
So those are like transient data scenarios.
Okay.
And I showed this table had the schema and data support where the data is always fully persisted, but there's also a schema-only mode where you don't persist the data. So you don't need to do any I/O when accessing the table. That's for you use those for these transient data scenarios.
Okay, yep, that makes sense.
Now let's talk about the case where you don't want to use it, right? Because there are those cases as well, right? So you need to use the right tool for the job. That is always very important. Use the right tool for the job.
Right.
In-memory OLTP, improved transaction throughput. Column store, improved analytics performance.
Okay.
Improved query performance, right? So if you have, for example, a query running slow and this query does aggregation of all your sales across regions, that is really like an analytic style query.
Yeah.
In-memory OLTP is not going to help you. Column store will help you
It's more of a
tremendously.
read scenario, right?
Yes, yes. And in-memory OLTP is good at certain reads, like if you read individual rows, point lookups, we call them, there in-memory OLTP is really good. But large scans, no, you want to use column
this is
store
where you want to
instead.
column store. Okay, yep.
And you can combine you can actually combine the two with SQL 2016.
Yeah, okay,
So you can get the best of both worlds.
Yep.
Also, if your perf bottleneck is outside of SQL Server, right? Because with in-memory OLTP, we can only optimize the path that is inside the SQL Server process, right? That is the core transaction processing is really optimized within the SQL Server process. But everything that happens outside, if it's
you can't
network
touch
traffic,
that.
if it is persisting to a slow log drive, those are things we cannot really optimize that well. One particular scenario is what we call chatty applications.
Yeah.
So applications that do lots of calls to the server, and each call does a very limited amount of work, but most of the time is spent in going back and forth between the client and the server.
Yeah.
I mean, I know of applications, like complex applications, where you have like user screens, where one user screen is 1,000 calls to the database, 1,000 different calls to the database. It's going back and forth, right? Back and forth.
Right.
So you're spending all your time in the network stack,
Yeah.
right? You're not doing a lot of transaction processing.
Yeah, that makes sense.
Of course, if you have a low transaction volume, you probably are not that interested in optimizing performance of your transactions. And finally, another thing that you do need to consider the resources that you actually have available, because it is an in-memory optimized technology. So
you have to have the memory
tables,
support,
Yeah, the tables live in memory.
Yep.
Not all your tables in a database. That's not necessary. You can have like historical data living in traditional disk-based tables. You can mix and match in your database, but the core transaction processing tables, they need to fit.
Yeah, if you've got a lot of, like you said, a high volume, high transaction table that you may have, like you said, millions of records going in. What's that? How much memory do you need to support that table, right?
Yeah. And you can very easily estimate the memory that you will actually need. So the Memory Optimization Advisor itself, this tool that we showed in Management Studio, that will actually tell you how much memory you're likely going to need.
Yep.
And you can also just look at what is the size of the existing table on disk. That's a good first approximation.
Okay.
The in-memory footprint is probably going to be smaller, but it's a good first approximation for your capacity planning.
Good. Oh, awesome. Okay.
Yeah, so that is what I wanted to talk about.
Good. All right.
Today.
Awesome. That's Joost. Thanks for coming. That's good information. I'm glad to see one of the things that because we had Bob Ward and Lindsay in here to talk about. Look, the 2016 SQL Server 2016. It's just faster, right?
Yeah.
And it's good to see that. Look, even natively with the changes that you've made, that within memory, that's also just faster, right?
Yeah, absolutely.
And it's phenomenal, right? When you can go from
450,000.
450,000 to a basement of 1 million,
Yeah,
right?
yeah.
Just by installing 2016, right? It's just faster, right? That's good to see.
Yeah.
Awesome. Joost, thanks for coming. We will have you back here shortly, but this is great information. And so, if they have questions, best way to get hold of you is?
This is my email address. I hope it's big enough on the slide.
I'm sure. Yeah, I'm sure it is. Yep. Yeah. So email Joost if you've got questions about in-memory.
Yep.
And we'll also put some in the show description, some links to where they can get more information, things like that. So,
yeah.
Joost, thanks for coming. It's been a pleasure always to have you. And
that was great to be here.
Yeah. Everybody, thanks for watching, and we'll see you next time.